we're starting. How is everyone doing? Like build? Cool. It feels funny that I'm having a talk on the Halloween day because as I was walking over to this building, I see a bunch of kids already wearing great costumes and running around, having a lot of fun. And then I walk into this building. It's all developer, Visual Studio, and conference. But it's all right. We're gonna DirectX and Visual Studio will be as much fun. As you can see, we have a very orange background here. So my name is Rong Lu, and I'm a program manager on the Visual C++ team. Today we're going to spend some time to talk about Visual Studio 2012 and what are the new features we have added for DirectX development. So pretty simple, straightforward agenda. We'll discuss a little bit about why you're building DirectX apps for Windows 8, why you want to consider DirectX as a choice. And we're going to spend most of the time in this hour within Visual Studio and show you a bunch of demos. Given this is a tooling talk, I will not go into details about what are the APIs available or teach you how to write code. I'm sure you guys already know that. But I will show you some of the new features we have added for graphics development in Visual Studio. Once we've done that, we're going to touch a little bit on Windows Phone 8 development. As you have seen in the keynote yesterday, Windows Phone 8 is out, and there's the SDK that you can download on the web. So I will mention what are the tools that's available if you're doing Windows Phone 8 development. I will leave us a few minutes at the end for questions. But if you have any questions in the middle of the talk, I don't mind getting interrupted. Just go ahead and ask. So before we actually start and dive into the content, just give me a quick show of hands. How many of you have been doing DirectX development already for living or for fun? So it's about probably a third. Thanks. The spotlights are really bright. So assume the rest of you guys are just curious to see what's going on here and might be thinking about doing some DX development in the future. I hope the talk will give both of you guys some new thoughts on what are the new things coming and what you might be dealing with once you get into DX development with Visual Studio. I'm sure you guys have seen this probably many times. The only thing I wanted to point out here is the DX box, because that's where we are going to focus on today. So as you can see on the left side, on the right side, there are a lot of desktop apps. You can use different languages. Of course, if you wanted to access DirectX APIs, you wanted to use C++. There's no change there. Now, what's new in Windows 8 is actually on the left side, what we call Windows Store apps. Now, there are three different UIs you can choose from. There's HTML, there's XAML, and there's DX. If you want to have full access to DirectX APIs, you want to get the best out of your graphics devices, that's the way you want to go. And in Windows 8, the only way you can access DX is by using C++. And that's what we are going to talk about today. Now, although DX are fully supported on both sides, so there's Windows Store apps and there's desktop apps, I am going to use Store apps in my demos just as samples. The only reason is because they are newer, and I want to show you how that is different from creating desktop DX apps. I will mention the differences. But I assure you that all the tools I'm going to show you today are going to work for both Store apps and desktop apps. There's no question about that. Now, just for fun, why do you want to consider DX? As we all know, there are multiple choices out there. XAML, HTML are great choices. When you are developing an app, why would you consider DirectX? One obvious reason is if you wanted to do real-time games, if you wanted to do high-performance games, you wanted to use DX because it gives you full access to your graphics devices and give you full control, and so you'll be able to get the best performance out of the hardware. Maps is another example of that. But in addition to the first fairly obvious reason, where we all know, I don't think it's a surprise to anyone that games, well, on all platforms, in all geography, over 50% of all the apps are games, or probably more. I don't think that's a surprise, but you'll see a lot of interesting games coming online, and DirectX is really the way for you to build some awesome interactive games. But in addition to that, we have also seen some other apps that are less obvious when they choose to use DirectX. One of the examples I show here is customer contacts. Normally, that's a line of business app, right? You're showing customer data, and why would you choose to use DX? In this case, this is quite interesting that the data is actually being visualized in 3D. Well, it's the same data, but if you look at this app, obviously it's more attractive, it's more fun, because you added all these intensive graphics assets to the app. It just attracts people's attention more than a plain table or grid. Some other example here, this one is actually showing network traffic around the globe. Now, instead of just showing the data, this one visualizes the traffic in a 3D way. It's also showing a globe, and it's going to spin real time and show you all the network traffic. Another interesting app that's actually up in the Windows Store today. If you search for Fresh Paint, you can see it. I never in a million years thought a paint app would be using DirectX. It's not a plain paint. It's a fancy paint. So this app is actually pretty nice. You can give that a try. It's simulating a canvas as if you are drawing, as if you are doing oil painting. So you can choose all different brushes, different color. It also has the blending effects that you can see if you choose two different colors, and then you paint one on top of each other, and the colors actually blend with each other, just like you will get when you're doing the actual painting. So it's pretty cool. This one is actually using DirectX as well. So just give you some thoughts on why we think DirectX has a lot of potential in making great store apps. In addition to obvious games, there are other great apps out there taking advantage of DirectX, and we really think that Windows 8 is going to be a great platform for you to build this kind of DirectX apps. So again, some of the scenarios I already mentioned there that you might want to consider DX. There are maps, there are visualization, data mining, image processing, and games, and more. The list could go on, and we look forward to see what kind of creative apps that you guys can come up with and put into the store. This is a chart that shows what Windows 8 provides as a platform for you to build great, successful DX apps. It has everything you need to create amazing apps. It has graphics, game input, audio, all the things you will need, all the APIs there for you to consume in your DX app. Now, DX 11.1, which is the version that ships with Windows 8, is supported in Windows Store app and desktop app. So you can choose between these two. And last but not least, we have great Visual Studio tooling support as another reason that you should think about building some great DX apps. And we're going to focus on that in the talk and the rest of the time here. Okay, enough talking. Now we're going to take a first look at the D3D app in Visual Studio 2012 and see how that works. Now switching to Visual Studio now. This is 2012 RTM. First thing I'm going to do is create a new project. I'll zoom a little bit so you can see it. On the left side, under Visual C++, there's Windows Store category. On the right side, you'll see two DX-related apps templates. One is D3D, one is D2D with XAML interrupt. We're going to touch on that a little bit later in the talk. Right now, we're going to focus on a pure DX app. So we're going to create that one. There's a little preview here shows you what the app is going to look like. I'm going to do build demo and hit OK. I'm just going to run it and see what the default app template does for us. That's a beautiful cube, and it's spinning. That comes with a template. So you notice this is a store app. So I want to go back to Visual Studio and show you what are the steps you need to take in order to make a store app, store DX app versus desktop. So there are three things you need to do to initialize the environment. So first of all, you're going to need to create a window to work with. Now, in the world of Windows Store app, you're going to create a core window as the object you're going to work with. And the second step, you're going to define a number of events to handle different events that this core window has that are unique to Windows Store apps. For example, what happens if the app is resumed? What happens if the app is suspended? So these are the unique things that are new to Store app compared to desktop apps. And last thing you need to do is to create your swap chain and then connect it to your core window. Now once you do all that, you have all the initial setup done. And everything else, whatever DX core you're making, all the data you're processing, and eventually you present all the data through the swap chain. So nothing changed there. So all the differences are actually the initialization in those three steps. Just want to show you real quick in code so you get an idea. We're going to start with the app object itself. So first of all, you're going to create and initiate the core app view by inheriting from core iframework view. This is defined in Windows runtime, so it is a WinRT API. And you define your WinRT type by saying ref class instead of class. So that's a keyword you're going to use whenever you define your own WinRT type. Once you do that, you will be able to get an object of core window. Again, this is defined in Windows runtime. And then this will be the core window that you're going to work with in your DX app. Now, second thing I mentioned is you're going to define a number of event handlers to handle all these different events. Window size change, what I'm going to do, what if the window is suspended or running in the background. So a number of things that you would do there. Now the third thing is you're going to create a swap chain and connect to the core window. Now let's see how we did that. Let's go to set window and see what we're doing here. of course, I'm defining all the event handlers. And then I'm initializing the call window. The way I'm getting call window is from this current thread. You'll see that the return type of this method is a call window. I'm going to go to definition again to here. This is where you're actually initializing all the DX objects. So I get the window, which is a call window. And now I'm going to create a number of device resources. First, I am going to see what's there. You will see a lot of code if you have done DX that look familiar, nothing different there. You define feature levels, you create new device from here, there. And that's basically what it does. The second thing you do is to create a number of window size dependent resources. This is actually where you create swap chains. Now you define a swap chain description. So in this case, you do, if the swap chain already exists, resize it. So that's the if statement. Else, if it doesn't exist, then you create a new one. So you define swap chain description with all the properties. And the key thing you do here is really this method. Create swap chain for call window. This is where you create swap chain, connect that to call window. And from that point on, you're on your own to do all the DX stuff that you normally would do. Now the good news is VS has this template that set up all these things for you. So if you don't want to do it, don't feel like doing that on your own, you don't have to. You don't even have to know all these things. But if you do have existing DX apps that you want to port over to be a store app, you might want to just add these things as opposed to start building a new one from scratch. All right, now let's take another look at what else is in the default project. Now, these are all pretty normal C++ code. And you will see we have some default sample shader code for you to start with. So this one has a pixel shader and a vertex shader. I'm going to show you the shader HLSL editor that we have. Now, you will actually see that it has colors. First time that it has some colors. It feels like a modern editor now. We have added the keyword colorization, and you can expand collabs just like you would expect. So that's the editor. The second thing I want to mention here is this time we have the shader compiler built into Visual Studio. So you don't have to worry about this additional step to compile the shader code. It's all set up here, and it just runs as part of your build. The second thing I want to mention here is there are some properties that you can set. For example, the shader type. In this case, it's a vertex shader. You specify type here, so it knows it compiles as a vertex shader. You can also specify shader model here. This is for, we all know there are different shaders are available in different shader models, so you have to be careful about that. But if you're using Visual Studio most of the time, all these things are set up for you by default. Why I say that is because we actually have templates for you to start with. So if you go to Add New Item, go to HLSL, we have a list of shader files for you to start with. We are supporting all the new shader types, compute, domain, geometry, just like you would expect. In this case, I can show you if I'm going to add a geometry shader. Now, this is the code that comes with a template. So it has some basic things already written for you. And if you check the property here, you will see this is set up as a geometry shader. So if you're using the templates we have, you don't have to worry about these settings. But if you're doing that on your own, then that's the thing you need to set. Just to show you what the experience looks like, I am going to build the solution here. You'll see that it already finished it, and it succeed. What I wanted to show you is HLSL shader compiler takes the HLSL file, takes in that, and outputs the runtime format CSO. And it's just being done as part of the build process. You don't have to worry about that. All right, so that's the first demo I want to show you. Just first look at a simple DX app. Just to recap what we just saw. I showed you a bunch of templates. There are project templates, there are item templates. We have a number of shader templates, and at the bottom there are actually two more, which I will show you a little bit later. That helps you to define shaders in a visual designer and helps you to create 3D scenes. We're going to get to that in a minute. We looked at HLSL editor and compilation. All the experience integrated into Visual Studio. You don't have to take any extra steps. You don't have to leave Visual Studio for anything. Now we know how to create a DX app, a Windows Store DX app. Now let's say we have done some code, we have built a game app, and let's see what we can do with Visual Studio to actually explore and debug this app. Because let's face it, most of the time we're just debugging our code and trying to figure out what's wrong and fix those. So let's do another demo and see how we're going to use the diagnostic tools in Visual Studio to fix some issues in a real app, which is a bit more complicated than the first spinning cube. So I'm just going to run it. It's a tank. And there's some interesting bubbles coming out of the tank. Has anyone seen pink bubbles coming out of a tank? So this is a 3D scene I can rotate, but from every angle I see pink bubbles. This apparently isn't right. Now let's see how we can find the issue and fix that. Stop the app. Now what we're going to do now is to launch the app again with our graphics debugger enabled. The way you do that is press this little button here. Where's my mouse? There. This is the graphics toolbar we added, and this one says Start Graphics Diagnostics. There's also a shortcut key for you to use if you wanted to, which says Alt F5. Again, it's going to launch the app. The only difference is now this time the graphics debugger is enabled and attached to the app. Now what we can do at this point is we look at the game and find out that something wrong with the game, and we wanted to capture a frame so we can inspect what's happening while I'm rendering this frame. So now I'm going to capture a frame. A shortcut key for doing that is print screen on your keyboard. Do that. If you look at what happened in the background in Visual Studio is a frame has been captured. A lot of information has been captured. We'll take a look at that a bit later. I can keep capturing more frames if I want while the game is running. I change the angle. I captured another frame. You can keep on capturing more frames while the game is running. If you want, you can go back and start inspecting. But in this case, I'm going to just stop the game and go back to look at it. All right, so some interesting information here. We can see all the bubbles are pink. Now the first thing I'm thinking, what might be wrong here? Maybe it's the texture I'm using, which doesn't have the right color. I should be using something more neutral, like a gray color, but instead I'm using a pink texture, which obviously could cause that. So before I do anything, I'm gonna take a look at the texture and see if that's right. I'm going back to Solution Explorer and trying to find the texture. Here is smoke. Notice that the format, the file I'm opening here is DDS, which is a direct design draw surface. Now, for the first time in Visual Studio, we updated the image editor that has been there for many, many years. Now we support new file formats, including the modern image formats, JPEG, PNG, and all that. But in addition, we also support DDS, which is a popular texture file format. Now we can see this is the texture I have for smoke, which the bubble is supposed to be like smoke. Looks like the color is pretty good. That's what I wanted, right? Some features we have in this new editor is, one of the things is we now support channels. So I can turn off red, turn off green. You'll see different colors. There's also alpha channel. Now you can see different channels. You can also apply some basic filter effects. You can do a blur. You can do a sharpener, all those things. You can also generate MIP level textures if you wanted to. We also support editing in this editor now. So if I zoom real hard to every pixel, I can start painting here. If I really wanted this to be a pink smoke, and can start using that. Of course, I don't want that. That's too ugly. All right, looks like we have got the texture right. Now let's see what went wrong when the game was running. Now, first of all, look at this image I captured. I select one pixel on it by clicking on it. Once I do that, it brings up this pixel history window that shows you all the draw calls that are used to render on this particular pixel. This is the final color it came up, which is pretty red. We can click on the different draw calls to see what each one does. Of course, the first one does clear render target, which clear everything, so the screen is black. Then I move on to draw the background. Right, this is the draw call happened at that time. Now the next one will be I'm drawing the actual bubble. So this will be the draw call I'm interested in, and see what went wrong. If I expand that, now you will see, just going to zoom a little bit. You will see the shaders that this pixel went through in the graphics pipeline. So there's vertex shader, geometry shader, pixel shader all happened in here. The output merger shows you the final result. You'll see the green color is the background that I drew first. And this color is what came out of the pixel shader. So both merged together came out to be the result. Apparently, something wrong with my pixel shader, that it's not giving the right color. So what I can do now is to debug this pixel shader. We see a little button here that says start debugging. Do that. Now, it opens, in this case, it's a FX file, but this is where my shader, my pixel shader is defined. You can, just like you would do doing debugging anything, you can F10, step over and just see what's going on here. I can fast forward just to go to the next breakpoint. You can hover over a variable and see the values. That's all like normal debugging. Now I look at it. This is the final color that I'm returning. And this color actually from COL variable. Now going back to how this is being defined is taking the input and add a random number to it. Let's see what the numbers are. XYZ represents our RGB values. Now in this case, looks like X value is a bit higher than I expect. That's why the final color is more red than I expect. Let's do something here to fix that. Just a little bit less of red, a bit more of green, blue. All right, I'm going to stop here. Now I probably have fixed the color issue. Next thing I want to do is, if you are a visual person like I am, you probably want to see visually what's going on in the graphics pipeline. Now we have this pipeline view that visually shows you each stage in the pipeline, and you can see what's going on at each stage. Now the first one is your input. That's your input model that represents the shape of the smoke. You can rotate here just to inspect if anything wrong. Okay, I think that looks good. This is the vertex shader, which takes that model and actually convert that into many dots, points that I will be using. Each point represents a bubble, which eventually should become my smoke. Now the third stage I'm going through is a geometry shader. That one takes all the points on the screen and convert that into squares. Well, actually 2 triangles, but each square represents the final bubble position and size. Once that it goes through, now pixel shader came into play that applies the pink color to all the shapes. Output merger blend the bubbles with my background, so there are more colors in here. Now what I want to do is to make the smoke a little more bigger, because these are very little bubbles. I want to have very heavy smoke. So I am going to debug this code. Again, that's the shader code, and as I step over, I notice that there's a line that says smoke size, which takes the input size and multiply by 0.2. I think we might want to have something bigger. Okay, so I change that here. I'll save that file, start debugging. I don't save that. Now let's run this app and see what it looks like. Whoa. The color looks right, the size looks right, but they are still bubbles. Something is still wrong. So I wanted to have all the bubbles. They're supposed to blend together. They're supposed to blend with my background. So they are smooth, they're transparent. So let's capture another frame and go back. Apparently something is wrong with the state of blending I'm setting. It's probably in my code. Now I'm gonna select a draw call again. This is where the bubble is drew. And I'm going to open my object table and just see how the blend state are set. zoom a little bit. So one of the objects I see here is object 82 that says blend state, which has a star, which means this blend state is active when this frame is rendered. Double click on that. It shows me the value of the blend state. So in this case, apparently it's set to false, which is supposed to be true, so everything can be blended together. Now everything is easy. I've just got to find out where in the code it is that I'm setting this value. So the other thing you can do is go to the event call list, call stack, where it shows you the code that you actually wrote. Double click back to my C++ code, and just real quick to find out where the value gets set. Find all references, and this is where the value gets set. This is where blend state should be set. Now if I run this, some nice smoke that came out of the tank. Cool? All right, let's go back. Just to summarize what we have just seen, a new image and texture editor that we support more formats, more functionalities. A mesh model viewer I showed you briefly, where you can see the 3D model and can rotate and see the different angles. I showed you a graphics debugger. Anyone here has used Pix before? A few, less than 10 people. So this is just like what Pix will be doing. This will be the new Pix in Visual Studio, so you don't have to leave Visual Studio to use something else. All right, now let's do the next demo. Now we have seen how to create a new app, how to debug an app if you have issues. Now let's do some design work. Or in some cases, there might be artists who will do that using some more professional tools. But in some cases, if it's a simple model or you are the only person on the team, you're going to do some design work. And you want to use one single tool to do everything. And that's what we're trying to do here. Let's go back to the previous app I created, the empty one. Now, what I wanted to do in this case is I wanted to create a 3D scene that has a globe. And I can rotate just to see. It has a nice texture around it. It has this spotlight. I don't know if you can see that clearly, but shining spotlight that's on the globe. I'm going to use that in another app. So I wanted to set up this 3D scene for the network traffic app I showed you earlier. OK, so we're going to start from scratch and see how long it would take for me to build that. OK, hold on. This is the right app. I'm going to use a new template, which is here. It says Visual Shader Graph. So basically, what I need to build is a shader, a pixel shader that defines what texture, what lighting, what spotlight that should come together to this model. So I'm going to do that and give it a name, globe. OK. So what this designer represents here, this is a final color. And this is its input. In the default template, it gives you the point color and outputs to the final color. It does basically nothing. So what we're going to do is delete that guy and keep the final color and do some design ourselves. Now I want to show you the toolbox that comes with so many options. there are different states you can use here, or different math, utility, parameters, textures. So almost everything you can think of when you design a shader. There are so many options that I have to use search. Now, first of all, I define a surface, and then I will put a light. I don't want everything to be in dark, so I'll put a light. Once I have these two vectors, I'm going to put them together by using a math dot. So the output of the surface connects to one of the inputs of dot calculation. Light connects to the other one. Now, once it does the calculation, if I output this directly to the final color, you can expect this is what my model will look like, or the pixel shader effect I will get. Of course, I don't want just a white ball. I wanted to apply a nice texture around this globe to make a real globe. So I wanted to do something to define my texture. I want to apply a texture sample here. It obviously takes in a UV coordinates. So I need to give it an input that defines that. And of course, now I have two RGB values. What I need to do is to multiply these two together. And now it goes to one of the inputs, and this one goes to the other inputs. And of course, the output value would be once this texture is applied to this sphere. Now, we don't want to have all these numbers and letters. We want to have a globe surface. So let's switch to a texture I have, which is this. Have that wrap around this model. Now, if you cannot see, I can zoom it, and you can actually see it in 3D. Okay, now real quick, let's add a spotlight, which I'm going to use specular to apply here. Now I have two outputs, and now I need another calculation just to put the values together. This guy, and you output to this, and you output to the final color. So if I zoom a little bit, you can actually see the spotlight here that's on the globe. Pretty cool, huh? Now, just to make it more fun, even more fun, how about let's make this globe rotating? Because the app I'm going to use will be showing a globe that's rotating, and I want to see what it looks like on the back side of the globe. So let's just add a time variable. Okay, so it outputs a time period. Now what I wanted to do is to have this texture moving slowly along the x-axis. So we have a texture here that's called pen UV. So what it does is modifies the texture coordinates by adding an offset over time. So that's exactly what I wanted. Let's drag and drop there. Of course, the UV now goes to here, and the time goes to time. Outputs goes to my texture sample. Okay, so the texture is going to move slowly. Now I've done that. What about previewing this real time? Because right now I cannot see any difference, right? Now we have this feature here that says render with time-based animation. Click on that. It's rotating. Okay, probably too fast and not the right direction. So just real quick, there are two properties I can set. One said speed on the x-axis and the y. What I want to do is please slow down on the x. Please do not rotate on y. Now it's rotating around x, and you can actually see that in 3D. Cool? Thank you. All right, I'm going to save that. Now, just real quick. Now, the last thing I need to do is to create a new 3D scene and then apply that texture, shader. We'll add that. Previously, I showed you you can view the model here. We actually support some simple basic editing as well. So you can actually add some objects. You can do transform, you can scale, you can move the position, you can do all that. But here I'm just going to show you real quick that you can apply the effect that we just created, which is under the new project, build demo, and this guy. There you go. That's like, what, 5 minutes? All right. The other thing I want to mention is for the DGSL file we just created, you might say, what if my tool doesn't support this format? We have thought about that. So one of the things you could do is to export this model to be a pixel shader HLCL format, so you can use it somewhere else. If I do that and just show you what it generates, you can again see that in the beautiful editor. And see, it's a lot of code. And with a designer, you don't have to write any of those, and you can start using this shader right away. Okay, so showed you a designer, basically a visual designer that has real-time rendering, intermediate state rendering. You can apply to models, you can export to HLSL. Now let's talk a little bit about interop between DX and XAML. There are 3 ways you can do this. First of all, if you have a XAML app, but you wanted to process some images, let's say, which is a lot of intensive computation that needs to happen. And DX is the way that helps you to process images. So you wanted to have a small size DX element inside your XAML app. If that's the case, you can use this control called surface image source. The only caveat to that is, in this case, you don't get to control when to present your content through the swap chain, because XAML framework will control that. You can update all the way you want, but XAML framework decides when it will present to the screen. So if you want real-time interaction, this is probably not the way to do that. But if you just want to do some processing inside XAML app, that's a good way to go. The second thing, which is an extension to the same control. In this case, it's called virtual surface image source. This is for the scenarios where you have large-scale DX graphics. For example, you have a map that you want people to zoom, to pan. So the area you're rendering is actually bigger than the screen. In that case, you will need to use this virtual surface image source because it's handling large-scale graphics. The last one is, in this case, it's the opposite. Now you have a DX app as your main app, but you wanted to use some XAML controls just for productivity, for easiness. You're doing all the heavy work just all by yourself, but on top of that, you can overlay some XAML controls, so you can get best of both worlds. In this case, you're going to use swap chain background panel control, and you still control when to present, when to update. You still get the interactive experience, but you also get the benefits of having XAML to help you generate some controls. So I just wanted to run an app. just to show you an example of that. Oh, sorry. What did I do? Okay, let me start this again. Okay, so that's the network traffic I was talking about. That's the globe I modeled myself. It's rotating. It's showing the network traffic. Now you'll see that the whole globe is rendered using DX. But all the texts, alerts or location, New York, or all these things are actually XAML controls. So these are laid on top of your DX surface. If we go back to Visual Studio, I can show you XAML controls that if you have done any XAML development, this will look very familiar. I just stop that. You'll see all these texts are normal XAML controls. And what you have here is swap chain background panel as your root control. It has to be your root node. But that's all you have to define. If I scroll down, everything else here are just pure XAML controls. To the end, it just close with swap chain background panel. So you get the best of both worlds. Okay. Oh, just to mention, you can actually capture frames out of those apps as well. We will not capture the XAML controls, but we will capture everything you render through DX. All right, last thing, I just want to quickly mention what it means if you're doing phone development. This is the app model. I will not go into details. There are other sessions there throughout the week that's going to cover that. But I wanted to point out that one thing, which is Direct 3D is a key scenario on Windows Phone 8. In fact, in this release, we added native C++ support. We added DX support so that you can do all those great apps on Windows Phone 8 as well. Again, you can do interop between XAML and DX as well. We just announced the SDK for Windows Phone 8. You will get all these things, almost everything I just showed you that worked for Windows 8. So you got templates, you got all these great design time tools, and that's another reason why you should consider DX, because if you have one working on Windows 8, it will not be too much trouble to port it over. And given we have the tools as well that works for both. So just to summarize, we have seen a lot of tools added in 2012. This is probably the most we have added for graphics development ever in Visual Studio history. So there's graphics debugging, a model viewer, an image and texture editor. You have a designer for pixel shaders. You have HLSL editor and compilation all built in. So with that, I think I still have 6 minutes for some questions. Yeah, go ahead.
When you started the visual debugging earlier, looks like you were getting an icon of kind of a camera with a lightning bolt on it. I didn't see that in the default set of toolbars that show up in Visual Studio. Do you know that this toolbar that it's on, you know what it's called?
Okay, so you're saying you cannot find a capture camera in Visual Studio, right?
Yeah.
Which should be here.
Oh, so it's not on your screen.
Um,
I mean, the presentation screen shows on.
Oh, sorry. There. This is what we call graphics toolbar. And the first button is when you start diagnostics. Once that started, you will see the last button will light up, which says capture the next rendered frame. You can capture from here in Visual Studio. Or
I'm actually not seeing that entire panel.
Okay, let me start this again. There. Oops. Can you see that? That's the button. You can either do this, or you can go to the app that's running and press print screen key to capture frame. Either way. Yes.
You show some FBX support at design time. Do you have something for optimizing meshes and loading them at runtime?
Okay, so the question is, for FBX files, do we do some optimization for runtime? So first of all, we have this build target built in Visual Studio where you can compile those FBX files into a runtime format. I don't think we control the actual convert process, but the conversion is built in Visual Studio where you can select, this is a mesh and I want to convert this into a runtime format. We do have that support. I didn't get to show you, but it's built in there.
I didn't find any library to load this particular format at runtime.
You didn't. Okay, so the question is, how do I load FBX file in my game? So okay, let me show you this real quick. Actually, have another app that actually does that. Now here you have an FBX file, right? What you do is you go to Properties and select this. It says Mesh Content Pipeline. Once you do that, when you compile, you build a project. It is going to, well, this one already built. But if I open the file here, this output of game level. Not in this folder. I cannot find it. It should be here somewhere. Is it here? Oh, debug, right. I went to the wrong folder. Disk. There. That's output format. Okay, so you got CMO by setting that property. And last thing you need to do is in your code, hold on, and find CMO. Whole project. Oh God. Okay. This is an example of how do you load CMO files so that you can use that scene in your game, in your app.
What is the mesh platform?
This? So this one actually was built into example. This is built in here actually as a sample. We haven't released that, but that's one of the things that we have built into the sample, so it's easier for you guys to load and to use. All right, yes?
The FBX file that will also work directly on the phone?
Would the FBX file directly work on the phone?
Once you run the pipeline?
Well, you would have to do the same thing, yes.
Okay, but it will work. I can model it straight. Yeah, it will work on the phone.
To be honest, I haven't tried, but I don't see why it would not. All right, I can, well, it's about time, so just want to show you some more things as closing. There are more related sessions. A lot of things were touched on in this session, but I couldn't get into the details. So there were a few sessions in the morning. Actually, you can go back to look at recordings. It was one session was about performance improvements in C++ compiler. That's going to benefit everyone who is using C++. You can get a lot faster